Okay, so I'll be discussing this question, and this video is essentially for my own future reference. But I'll be uploading this on YouTube, and if someone else wants to take a look at this, they are free to do this. But this is primarily for my own reference. So I'll be explaining this to myself, my future self. So anyway, so what do we have here? So this is one of the questions in microeconomics 2x2 production general equilibrium, and the question is, there is a small so we have a small price taking economy. So the prices will be given, and these are the labor endowments, and the prices of good 1 and 2 are this 1 1. So that is what we meant by that this is a price taking economy. So whatever we are going to do, the prices are exogenously given. Now the economy produces capital intensive good, which is good 1. So good 1 is capital intensive, and labor intensive is good 2. Now what does that mean? It basically means that the unit to produce one unit of good 1, to produce 1 unit of good 1, more capital is used when compared to good 2. So if so for instance, if to produce 1 unit of good 1, I need 5 units of capital. To produce 1 unit of good 2, I use 3 units of capital. And the same thing is going to hold for labor intensive, but the other way around. So the unit labor requirement for producing 1 unit of good 2 is greater for good 2 when compared to good 1. So good 1 is capital intensive, good 2 is labor intensive. Now, and the production that is used, that is CRS technology, which I have not mentioned here. So it was mentioned somewhere around here in the question, that so these are the production functions. So for good 1, it is a function of labor and capital, and it is L1 to the power 1 by 4, K1 to the power 3 by 4. So this is CRS. And for good 2, is just L2 to the power 1 by 3, 3/4, and K2 is 1/4. So these are the production function, CRS production functions. And now what do we need to do? First we need to find the conditional demand for factor inputs. Now essentially we need to do the entire general equilibrium thing. We need to find everything, but there are two ways of doing this. So there are two ways to do this. One is the profit maximizing approach, and the other one is cost minimizing approach, right? So both of them yield the same result. They are dual of one another. In this particular question, it's better to take the cost minimization approach, because before we actually find the general equilibrium, that is question number C, we would have already derived the conditional demand and the unit cost function. So half the work is already done if we do A and B correctly, and we are just going to use these two information that we have derived in A and B to find the general equilibrium in question C. So we'll be minimizing cost, and now so that is what we are going to do. So let's start off with the solution, right? So A, so we need to find the conditional demand. So let A11 and or let L1 star comma L2 star be the conditional demand for labor for good 1 and 2 respectively. Similarly, let K1 star and K2 star be the conditional demand for capital for good 1 and 2 respectively. And okay, so we'll be kind of referring to MGW for this. So this entire the theory for this is discussed in MGW chapter 15, specifically section 15.d. So the reference for this is MGW chapter 15 section D, right? So I'll be referring to this, and yeah, that's that. So this now in MGW, these things are kind of, so not in this particular notation, they have used A11 to denote the conditional demand for good 1 by firm 1, where this subscript is for represents good, and this subscripts the right one represents the firm. So A12 would be the conditional demand for good 1 by firm 2, and basically firm 1 only produces good 1 and firm 2 only produces good 2. So that is the notation used in MGW. Anyway, so right, so now we need to find the conditional demand. Well, how do we find the conditional demand? To get the conditional demand, we would have to minimize the cost subject to some specific level of output. Now what we are going to do is we are going to do this for, we are going to derive the unit conditional demand, and here we are going to find out the unit cost function, right? And why are we going to do this? Because it is easier, and since we are given that the technology is CRS, it's constant returns to scale, we can just, so if you find the unit cost, then we can find the cost of any level of output. We just multiplied by that number, and this we wouldn't have been able to do if it was anything other than CRS. Had it been IRS or DRS, that wouldn't have been possible. For CRS it's possible. So we'll focus on finding the unit conditional demand and unit cost function. So how do we do that? So this is for firm 1, and we'll have to do this for both firm 1 and 2. So firm 1 only produces, by the way, only produces good 1, right? So firm 1 only produces good 1. Right. Now what else? Right. So the firm 1 would minimize its cost. Now what is cost? Cost is basically my wage times labor input by firm 1 plus rent or whatever the price of factor input 2 is, times this, subject to uh, f1 of L1 K1 should be equals to or greater than or equals to 1, right? Now, because of certain conditions, that is basically the so the Lagrange, so we'll have to we'll have to form the Lagrangian here, and uh, the Lagrange multiplier should be positive. So by the KKT conditions and the complementary slackness conditions, we are going to kind of get that uh, this the the constraint should be binding, right? So the constraint should hold with an equality sign. So that is something that we are going to have. So uh, so by complementary slackness, what we so f of L1 K1 is going to be exactly equals to 1. So this is basically equivalent to minimizing over L1 and K1. Sorry. So what we'll essentially be doing is we will be minimizing the cost over L1 and K1 subject to what is F1? F1 is essentially L1 to the power 1 by 4, L1 to the power 1 by 4, K1 to the power 3 by 4, which is equals to 1. So our we form the Lagrangian as follows, right? So it is going to be the this W1 L1 plus R K1 plus lambda times 1 minus L1 to the power 1 by 4, K1 to the power 3 by 4. That's that. Now the first order conditions. So now we basically need to solve for L1 and K1, and so by first order conditions we are going to have this should be equals to 0, which implies that okay, there is no 1 here, right? Yeah. So plus lambda times minus 1 by 4 L1 to the power minus 3 by 4, is it? Yeah, minus 3 by 4 K1 to the power minus just 3 by 4. This should be equals to 0, and we can we have essentially a minus sign here, so we can kind of do this, right? And it can go there, and ultimately your just lambda would be 4 times L1 minus 3 by 4 K1 3 by 4, is it? So this goes there, and then whatever this is, this goes here. Wait, let's not just, I mean, it's better to not jump steps and do it right. So we have wage equals to lambda times 1 4 L1 to the power minus 3 by 4 K1 to the power 3 by 4, and that is essentially equals to K1 by L1 whole to the power 3 by 4, right? So what is going to be, so we can take the 4 there, so we are going to have 4 wage equals to lambda times K1 by L1 3 by 4, and what is going to be my lambda? Lambda is going to be, well, 4 times wage and L1 by K1 to the power 3 by 4, right? So this is, let's just use a different color because it's a different thing. So this is one thing that we have, right? Right. Now again, so we do this kind of the same thing for K1. What do we get? We get R plus lambda times minus 3 by 4 L1 to the power 1 by 4 K1 to the power minus 3 by 4, sorry, no, minus 1 by 4. This is minus 1 by 4 and this is equals to 0. Now we kind of do the same thing, we isolate lambda, right? So R is going to be lambda times 3 by 4 L1 by K1 whole to the power 1 by 4. This is essentially equals to 4R by 3 and K1 by L1 to the power 1 by 4 equals to lambda, right? So this is the other thing that we have. Now from these two equations we kind of have that, so okay, and we have one more thing, right? So the constraint itself, which is just L1 to the power 1 by 4, was it? Yeah. K1 to the power 3 by 4 equals to 1. So we have these three things. Okay, now so from these two equations we get that, what do we get? So we can just divide them. So let's say this is 1, this is 2, and uh, 1 by 2, right? So 4 times, so let's just write it in terms of K1 by L1 so that we can cancel things out, or so that is just L1 by K1, let's say L1 by K1 to the power 3 by 4, that is divided by 4R by 3 L1 by K1 minus 1 by 4, right? So to the power minus 1 by 4, and that very nicely, so this 4 and 4 is going to cancel out, so this will cancel out, this will cancel out, we are going to have a 3 here, W by R, and this goes up, becomes plus, we have L1 by K1, right? So this entire thing is 1, or L1, or we can just write it in terms of L1, So L1 is 3 1 by 3 times R. Let's just write it in one shot. So it RK1 by 3 W. So RK1 by 3 times wage right. Okay, and from here what do we have? So we can just put this, putting this in, let's say this is 3, we get, what do we get? We'll get the, the L1 star, which is nothing but the conditional demand for factor input label. So what do we get? We get R times K1 by 3 wage whole to the power 1 by 4, K1 to the power 3 by 4 equals to 1, and so here the K is going to be just K, and we are going to be left with R by 3 omega 3 wage 1 by 4, which is equals to 1, which implies K1 star is nothing but 3 omega by R to the power 1 by 4. So this is right. So this is the conditional input demand for capital. Now again putting this in here, so putting K1 star in L1 equals to RK1 by 3 omega, we get, what should we get here? We will get L1 star as R by 3 omega times 3 omega by R power 1 by 4. Well, we can just R by 3 omega, this is R by 3 omega to the power minus 1 by 4, right? We reciprocal it. What should we get? We get so R by 3 omega to the power 3 by 4, right? Right, that is what we get. Now we need to do the same for firm 2. So this is a quite a big sum. I mean, if we kind of use this symmetry, right? So this is essentially the powers are flipped. So I am assuming that there is some easier way to use symmetry here and just come up with the K2 star and L1 star directly, but I am not really sure how you would do that. So let's just not take any chances and just do it. So firm 2 only produces good 2, right? So this guy is going to minimize over L2 and K2. And what is this? What are they going to minimize? They are going to minimize wage times labor 2 plus rent times capital, subject to F2 of L2 K2 being less than or equals to 1. Sorry, greater than or equals to 1. Right, so and again, due to complementary slackness condition, uh, the constraint would be binding, and we'll form the Lagrangian as follows. It would be LW2 plus RK2 plus lambda times 1 minus L to the power 3 by 4, right? So L to the power 3 by 4, K to the power 1 by 4, this is 2 for form 2, and so this is going to give us R plus lambda minus 1 by 4 L2 by K2 whole to the power 3 by 4, which is going to give us R equals to lambda by 4 L2 by K2, 3 by 4, which is going to give us lambda equals to 4R K2 by L2, 3 by 4, right? And this is going to give us what? Right now, and we are still going to have that. Right, so we have these three things. And we divide this to get, so I'm not going to write everything, or I will, maybe, who knows. Let's say this is 1 dash, this is 2 dash, this is 3 dash. From 1 dash and 2 dash we get what do we get? We get 1 equals to 4r K2 by L2 to the power 3 by 4 by 4 by 3 K2 by L2 minus 1 by 4, which is just 4 is going to cancel out. Wait a sec. We will have 3r by omega and K2 by L2. That's it, right? Something very similar we found here. And this gives us L2 as 3r. Oops, K2, right? No. L2 is just 3r by omega times K2. Putting that in 3 dash, we get, okay, are we missing something? I should hope not. We get 3 by 4 K2 to 1. This implies K2 star would be W by 3R power 3 by 4. And again putting in L2 equals to 3R by omega K2, we have what do we have? L2 star equals to 3R by omega by 3R 3 by 4, which is 3R by omega 1 by 4, right? So star is 1 by 4. This is what the conditional factor demands for form 1 and 2 are, and indeed we got something very similar right here and here. So here's 3 yeah, it's just it got flipped, I guess. It got flipped and the powers changed. Anyway, so that is question 1. So we are done with question 1. Now we need to find the unit cost function for production of both the goods. So this is relatively easy. So B, so the unit cost function, which is unit cost function for firm 1 and 2 are essentially C1 L1 star, K1 star, this is a C not an E, and here we have C2 L2 star, K2 star. Right, Now what was it was this, right? So omega times what was L1 star. L1 star was r by 3 omega to the power 3 by 4. So r by 3 omega to the power 3 by 4 plus, here we have r times 3 omega by r to the power 1 by 4. Can we simplify this? I hope we can. So instead of writing it like this, we can flip this. So let's make this minus 1 by 4. We can do this r by 3 omega, right? And we can take r by 3 omega, let's say r by 3 omega to the power 3 by 4 we can take common, so we are going to have this plus r by 3 omega to the power minus 1 by 4 minus 3 by 4, and that is going to be just minus 1, so we can again flip that around. So it would be 3 omega by r omega by r, and we are going to have nothing here. And so basically I'm doing this because I do not have space here, I do not want to make this longer. So this is all just calculations, and r are going to cancel out, and we are going to be left with omega plus 3 omega, so just 4 omega, right? So just directly write that. So we are going to have 4 omega here. So 4 omega times r by omega to the power 3 by 4. This is the cost function of firm 1. Similarly, the cost function of firm 2 would be this, right? And what was L2 star? It was just 3r by omega 1 by 4 and let's say 3r by omega to the power minus 3 by 4. We take 3r omega to the power minus 3 by 4 as common, and what are we going to have? We are going to have 3r by omega, so 1 by 4 3r by omega 3 by 4 plus r. This is just going to be omega by 3r, right? 3 by 4. This would be just 3r by omega. Okay, there was an omega here, right? We missed that. So it would be just 3r by omega, and omegas are going to cancel out. We are going to have 3r plus r, so which is just 4r, right? So something very similar to this. Right. So where were we? We were doing this, right? So we have got the two cost functions. Now the thing is, we need to, so that was it, right? So that was it. Now we need to find the general equilibrium. So how do we find the general equilibrium? So the general equilibrium condition, so this is question number 3, not 3, basically C. To find the general equilibrium, we are going to have to use the condition that, so this condition is explained in, I guess, MGW. So refer to equation 15.d.7, which basically states that C1 of W1P sorry, W1 W2 should be equals to P1, and C2 of W1 W2 should be equals to P2, where these are our input price vectors and this is my output price vector. These are given. So what is it in our case? So for in our case, C1, which is 4W times R by W to the power 3 by 4, 4W R by W to the power 3 by 4, this should be equals to P1, which is basically equals to P1, right? So P1 is given to be 1 in the question. It is given somewhere here, right? So this, and similarly C2, which is omega by 3R by 3 by 4 by 4R should be equals to 1. So now we kind of have to solve for, okay, didn't we? Yeah, we had a 3 here, right? We missed a 3 here. We had a 3 here, we missed a 3 here. So now we need to kind of eliminate W's and R, right? So okay, so I guess, okay, and this is also equals to P2. Now we have to kind of notice something. I don't know what to notice, but if we consider C1 by C2, what is going to happen if we do C1 by C2, right? So dividing both of these, so C1 by C2 is just 1 because 1 by 1, which is what is C1. So we have 4W times R to the power 3 by 4 and 3 omega to the power minus 3 by 4 divided by omega to the power 3 by 4, 3R to the power minus 3 by 4 times 4R. So what are the things that is going to cancel out? 4 is going to cancel out. So 4 is going to cancel out, and okay, notice that we have 3 to the power minus 3 by 4 on both sides, so that is going to cancel out. So 3 is going to cancel out. We have R to the power minus 3 by 4, so that is going to go on top. So we are going to have just R there. Okay, again, are we missing something? Okay, so it is going to, so it will just be R 3 by 4 plus, no, that is not, it is going to be R to the power 3 by 4 plus 3 by 4. There should be a 1 by 4 somewhere. Why do we have this everywhere? Just a sec. Right, so wait, is the voice, yeah, voice is working. So yeah, so we get these two expressions and we divide one by the other. I was getting stuck there, but I figured it out, and this is what we will get. And essentially from there we can say that W is basically equals to R. So this is something that we are going to get. Now if we put this into any one of these expressions, we are going to get explicit values for W. And if we do that, suppose if we do that here, right, suppose we do that here, what do we get? We get, so putting W is equals to R in C1 equals to 1, we get 4W times W by 3W by 3 by 4 equals to 1, which, so this cancels out, this cancels out. So omega is just 1 by 4 and 3 to the power 3 by 4. So 3 to the power 3 by 4 and 4. So this is what omega is, and therefore r is going to be the same, right? So 3 to the power 3 by 4 by 4. And that is that. So we have found the equilibrium this. Now we need to find the factor allocation, right? So how much factor everyone uses. Now to do that, we would have to kind of use this relationship that and this is basically in MGW, this particular relationship is given by figure figure 15.d.5, and here basically what do we have is that the Z11 star by Z21 star should be equals to the ratio of unit factor demand. This and Z12 star, Z22 star should be equals to A12 of this and A22 star of this, right? So in our case, so these are kind of input demand. So Z's are the input demand, and yeah, right. So this is what we have, right? And this is basically, again, so this is the input demand as well. But the thing is, now we know what this ratio is, right? We know what this is. So for us, L11 is basically N1 star and A21 is basically K2 star, right? So this is different notation. MGW uses different notation than we are giving in this question, and we have this ratio with us, right? So what is going to be, so basically L1 star evaluated at 3 to the power 3 by 4 by 4 is what? So what was our L1 star? L1 star that we had was R by, so we know that R and W are the same, so they are just going to cancel out, right? And we are going to have 3 to the power minus 3 by 4, right? So we are going to have 3 to the power minus 3 by 4, and similarly K1 star would be, what is K1 star? What was K1 star? Again, WRR, so it is going to be 3 to the power 1 by 4. 3 to the power 1 by 4. So what would be L1 star by K1 star? It is just 3 to the power minus 1, so 1 by 3, right? So this is basically this thing. Therefore, by this market clearing condition, no, this is not the market clearing condition. This is the equilibrium factor allocation. So from here we can get that Z11, right? So Z11 would be what? Z11 would be labor allocated for production of good 1 by firm 1 is equals to 1/3 of, you just cross multiply the capital used for production of good 2 by this. So yeah, so this is one thing that we have. Similarly, we can find this for the other firm also. Right, so in this, but basically, um, or it's just better to just get rid of this. So this is the ratio in which the firms are going to use the Lieberman thing, and similarly, what is my L2 star? L2 star is just 3 to the power 1 by 4, 3 to the power 1 by 4, K2 star would be 3 to the power minus 3 by 4, and when we put it here, we essentially get that the labor that first so labor that the second firm uses is okay, L1 to L2 to, right? So it's just 1 by 4, so it's just 3 times of K2. So we have these two conditions. So we have, and plus we have the market clearing condition. Market clearing condition is basically factor demand should be equals to factor supply, right? So basically L1 plus L2 should be equals to what? What was our factor supply? What was our endowment? Our endowment was just 10, 20, right? So this should be 10, and K1 plus K2 should be 20. Now from here, if we add both of them up, this basically says that 1/3 of K1 plus 3 of K2 should be equals to 10, which basically implies that K1 plus 9 K2 should be equals to 10, and then we can solve for this. So if we so from here we have, so 10 minus 9 K2 is equals to 20 minus K2, right? So it goes there, we have 8 K2. Wait, are we doing something wrong? We must be doing something wrong. Yeah, we are doing something wrong. Just a sec. Right, so yeah, so so here was the problem that we were facing. This shouldn't be okay. So this was 10, but we forgot to cross multiply, right? So this should be 30, and if that is 30, then basically from here we can say that K1 is essentially 20 minus K2. From here we can say that K1 is 30 minus 9 K2, right? So therefore 20 minus K2 should be equals to 30 minus 9 K2, which should be, if this comes here, we should have 8 K2 being equal to 10, right? This implies K2 is just 10 by 8, which is what? 10 by 8, 5 by 4. Yeah, this is just 5 by 4. So what should be my K1? Well, my K1 is 20 minus 5 by 4, which is 80. Um, 75 by 4, right? So this is the allocation of capital. Similarly, we can find the labor. So here we found out that labor is going to be in this thing. So labor 1 is going to be 1/3 of K1. So K1 was this, so it would be 1/3 of this. So it would be 75 by 12. Or I guess you can cancel this out by 3. So you will have 2, 5. So it is 4, right? So this is 25 by 4. And L2 would be just 3 times of K2. So it would be 15 by 4. Right? So my final allocation, so what L1 uses and what is L1 K1, it is just 25 by 4 and K1 is 75 by 4. Your L2 K2 is 15 by 4 and K2 is 5 by 4. What your WR is, we found W to be R to the power 3 by 4 by 4, right? So R, sorry, three to the power 3 by 4 by 4, right? Sorry. So 3 to the power 3 by 4 by 4 and 3 to the power 3 by 4 by 4. And we can just plug these two things into the production function and we'll get it. And as for the final thing, I'm kind of running out of time, so I would have to leave that, I guess. But so we did this. And consider the price taking economy, how this thing is going to happen. So right now, so we need to use the Edgeworth box. So this is question D, right? And if we draw the Edgeworth box, right? So I guess we have more capital or more labor. We have less capital, we have more capital, less labor, right? So it shouldn't be like this. It should be something. Should be something like. So this is my producer 1, this is my producer 2, this is L1, this is my K1, this is my L2, this is my K2, right? And this entire is 10 and this entire thing is 20. And what did we have? This ratio was, so L1 by K1 ratio was 1 by 3rd, right? So we have something like this. So this slope is 1/3, right? So I'm not going to write it, or maybe I can using a thinner thing. So this is 1/3, and for the second producer it was 3, right? So so it is better if you if we do this, and it was 3, so it would be like steeper than the 45-degree line, right? So it would be steeper than the 45-degree line. So it would be something like something steeper than the 45-degree line. Let's draw it like this. Oh, okay, that's nice. I guess I can. Can I do this? No, turns out I can't. So this is what is going to be the Edgeworth box, right? And this slope is just 3, right, as we found out. and this is 1 by 3, and this was, and this is the factor allocation that we found out. We've right, so I'm not putting the numbers here, but this is what. So okay, so what was this? L1 was just 25 by 4, so this is 25 by 4, and this would be 15 by 4, right? K2 was 5 by 4 or something. K2 was 5 by 4. Okay, we might be, I don't, I hope not, but I guess we are doing something wrong. And this was 25 by 4. L1 was 25, K1 was 75 by 4. 75 by 4, are we sure? Okay, so this is the thing, and basically here we are going to have an isoquant, so this is the isoquant for first, and we have an isoquant like this for the second producer, and this is where the equilibrium happens. Now what is going to, so the question was, what is going to happen, that is comparative abundance So for that, basically for the second question, it is the Edgeworth box would change. It would be something like this, and since they are still using the same production function and same everything, they are still going to be from this is 1, this is 2, and this slope would be still 1/3, and this would still be 3, and this is still going to be somewhere like this, and how is everything else going to differ? Well, there is going to be no, okay, so I am going to just make some claims. The factor prices won't change. Why? That is because of Stolper, Stolper, Stolper Samuelson theorem, right? So the only way the the factor prices will change is if the output price changes, right? And since the output price is given to be 1,1 for both these economies, there is going to be no change in factor prices. It is going to stay the same. How is going to be the level of output differing? So the output of good 2, which I hope was labor intensive, will rise, will be more in economy 2 than in economy 1. Why? Because of rib RYB, rib CZYNCKI. I'm guessing I'm spelling this wrong, but this is Rybczynski theorem, right? And factor use, how the factor use changes? Well, for that we would have to solve this. So what exactly? So these equations are not changing, right? So these equations are not changing. That means these are still going to hold for the second economy too. And why are they changing? Because the factor of the technique of production isn't changing. So had the technique of production changed, these would have changed, but they are not changing. And this also depends on this, right? So the W star, and W star isn't changing too. Why? Because of Stolper-Samuelson theorem. The prices need to change in order for this to be changed, but that is not happening. So ultimately, what do we have? So what is changing? This is changing, right? So in economy 1, L1 plus L2 was 10. In economy 2, L1 plus L2 was 20 in economy 1. In economy 2, this is changing to be 20 and this is changing to be 10. So we need to solve, these two equations are going to stay the same and these two equations would change, and then we'll need to solve. And then we are going to get this particular, factor use. And then we can comment on the factor use. So recompute factor use. And that is how you kind of do this entire sum. This is one hell of a sum and this is very big, but I guess that's what you have to do. So that was it. Thanks.